Hello and welcome to Aerotech's Automation1 version 2.8 Motion Control Platform Release Update. Aerotech is a company that solves your toughest precision motion and automation challenges. Automation1 is a motion control platform consisting of software-based controls and developmental tools, PC and drive-based control hardware, and hardware-based drives for servo motors, galvo laser scan heads, and interfacing with other devices. In this video, you will discover new features available in the 2.8 Automation1 release, including features that are no longer in beta, including 3D plotting, cutter offset compensation, work offsets, I file support, task variable support, variables and IO GUI improvements, including new features, including flexible linear gantry support, G-code custom T-codes for tools, data collection presets, and an example PSO code for the GL4, and improvements to the studio application, controller, help files, machine apps, and also drive hardware. My name is Patrick Wheeler, and I'm a product manager for Aerotech. Let's talk about features that are no longer in beta. Starting off, our 3D plotting tool, which came out earlier this calendar year, which allows you to configure 3D data signals in the Data Visualizer module. Configure signals dialog. Here you can add data signals to the 3D configuration, and it automatically adds them to the 1D configuration as well. You're able to trigger 3D data collection using AeroScript functions and Data Visualizer controls. And you can view the collected 3D signals in the following views: a regular 3D view and a combined 3D and 1D view, which is what you see on the screen right here. So please let us know what other plotting tools you would like to see. Also coming out of beta in this release is a cutter offset compensation feature. This allows you to compensate for the X, Y, and Z offsets of a cutting tool. You simply configure this with AeroScript, and you enable it and disable it with G-code. Please be mindful of lead-on and lead-off moves when using these features. Another tool that comes out of beta in this release, which was previously released a few cycles ago, is our new work offsets feature. This allows you to program motion relative to a fixed point. 100 work offsets are available with the controller, and 6 work offsets are natively supported in Automation1 G-code. They are available across all controller tasks, and there's a few help topics that I've referenced here that can help you learn more about work offsets. To use work offsets, you would simply configure the work offset using the AeroScript function. You would enable it using the G-code function. If you need more than these 6 standard G-code functions, or 6 work offsets, you can use work offset enable, which is an AeroScript function, and you can even use that to create custom G-codes for additional G-code based work offsets. If you want to disable your work offset, please just use the G53 command, or of course, you could also use a work offset disable AeroScript command. And to suppress your work offsets, you can use a G153. Now fully supported is I files. I files contain values that correspond to a specific key. You can put these keys and values into groups or sections for organizations. And I file functions include the ability to read a value, modify or create a new value, search to see if a section exists, and delete a section or key. These are AeroScript functions inside of the controller. Common machine builder use cases include saving and accessing machine and tool positions, and saving and accessing process set points and values. The I file support works well with the new cutter offset compensation, work offsets, and also process specific parameters, as well as our new custom T-codes, which we'll talk about here in a second. Looking at the images on the right, you can see that you can actually open an I file inside of the programming module inside of the developed workspace in Automation1 Studio. Doing so enables a feature-rich text editor that colors your different sections and keys differently to quickly view and access information visually inside of the programming module. It's a very nice user experience for I files that has been released in 2.8. Also now out of beta in 2.8 is task variables. So each task will have a task array variables for reals, integers, and strings. This was introduced in an earlier release and is now officially out of beta. This is used to communicate between iterations of a program that are running on the same task. The number of available task real variables is specified by the task reals, real integers by the task integers, and task strings specifies number of strings. These are different from controller global variables, and you cannot use task array variables to communicate between tasks that you would use global variables for. Going along with some of these variable improvements, are improvements to the variable and IO GUI inside of the Studio application. The first thing of note is that task variables are now shown in the variables and IO module. You can now see things like string task variables updated in the GUI as you run a program. And if you can see, this little program I wrote for this demonstration has 3 task strings being updated that are now visible in the variables and IO window. Task string 0 says you can now see task ... Task string 1 says variables in the ... And task string 2 says variables in IO module. So a complete sentence written to 3 separate string task variables. New features in Automation1 version 2.8 include flexible linear gantry support. It's supported right now in the device catalog, and this enables you to configure a custom flexible linear gantry device or devices, and then in machine setup, you can use these devices as a part of the system configuration. In the top right is a screenshot of actually being inside of Studio application in the device catalog, where you can choose decoupled control for a linear flexible gantry. In the bottom right is a picture of machine setup, where you would actually create axes by associating drive hardware with the axes of this custom flexible gantry. And then the bottom left is just a nice little graphical representation of the R and theta motion that is capable of being programmed to with the new linear gantry support. We formerly and currently still have what's called a rigid linear gantry support. In that case, because it is rigid, the theta axis cannot be programmed to. Now that we've opened up device catalog and machine setup for flexible linear gantry support, you can actually build a gantry with the Automation1 Studio application and Automation1 controller that includes flexible joints on your gantry, such that you can actually program motion in the theta direction. This is all building on top of the core feature, which is the Automation1 gantry control, which includes this MIMO style decoupled control capability. Also new in 2.8 is G-code custom T codes. Really happy with the way we implemented this feature in the controller. You can now add custom T codes to the Aerotech G-code dialect. And that's a very simple thing, but it's a very powerful thing. That means the Aerotech G-code can act even more like a full CNC controller. And you can use these custom T codes to create a custom AeroScript routine that you can execute by using the T command. You use custom T codes to make a tool selection routine together with a custom tool table definition. And what does this all mean? Well, let's look at an example. First, we're going to show you on the far right, number 1. I'll use my mouse for this. You see that there's a tool table configuration, and these files are actually in the help file. You can copy and paste these into the programming modules I have to deploy a quick and easy example of building a tool table in Automation1 Studio. So this INI file has a series of different characteristics of a tool. X, Y, and Z axes are X, Y, and Z. The tool radius wear, the offset values, the cutter length values, the feed rate. They're all programmed and they're different for tool 1 and for tool 2. And all this information is laid out in the INI file format. Going over to the tool library AeroScript library file, that's where you would read in all of these INI file values using these nice file INI read value commands. And then you create the library G code, which points back to these values that you read in, depending upon the actual T command you've called from your program. So in this program, if I call a T1, it's going to call tool 1, and tool 1 is going to use these read INI file values to set all of these tool 1 values to that tool. If I called T2, issued a T2 command in my program, then I would get all the T2 values. These numbers over here are default values that if it didn't find a value inside of the INI file, it would default to 0.0, and you of course can write some control logic around that, what to do if you get these standard values instead of the actual values that are in the INI file. So why is this powerful? This is powerful because tool tables are now 100% up to your imagination or your customer's imagination as to what they want a tool table to include. Any of these things can be parameterized in an INI file format, and that might mean traditional milling tools, or it could mean laser tools or a camera tool. Anything that a machine builder could imagine being accessed through a T command can now be set up using the INI file support in Automation1 and these nice AeroScript INI file functions. This enables, of course, a really nice, well-rounded out set of features for machine apps as a CNC interface builder. Machine apps has been developed over many release cycles, and at this point in its life cycle, it has really nice features such as ability to deploy custom colors and brand elements. We just released in the last release the feed, hold, retrace, and MFO capabilities. You can add programming, camera, and data visualizer modules. Many more things, are there to choose from, many more modules. And then you can also create your own custom module with .NET. Okay, so the T commands, branding, colors, standard CNC style controls such as feed, hold, retrace, and manual feed rate override. All of these things makes the machine apps a powerful CNC interface builder, and probably the quickest way to build a custom CNC interface on the market today. Also coming out in Automation1 2.8 is what we call data collection presets. What are these, right? Well, presets are predefined data collection configurations. They are stored on your controller, so they're stored on the ISMC side of the product, and they can be applied using the configure signals dialog. Presets can be added to your controller by either uploading existing presets from a different MCD file. You can create a new preset with the data collection presets module in the configuration in the configure workspace, and there's a screenshot of that below. Or you can create a new preset from your current configuration in the configure signals dialog, or from your current configuration in the edit plot dialog. Both of those are part of the data visualizer module in Automation1 Studio. So let's take a closer look. In the configure workspace, if you click on controller data collection, and that's where we are here, the configure workspace data collection underneath controller, then you will get the data collection presets module show up, okay? If no presets are configured, you'll be prompted to create one. If you'd like to do that, you can go ahead and do it. If one or more presets are configured, then you'd use the menu bar to add one, edit one, copy one, or delete a preset. If we're in the edit screen or the adding screen, it's going to look a lot like the configure signals dialog inside of the data visualizer. But instead of configuring your current data collection, you're configuring a preset. So you can walk through the steps of configuring signals that you want to collect, and then when you're done, you'll have the option to save it, and you'll save it as I have here, the name, the collection period, the number of points, and a description of what the preset is for. And this is very convenient for people to use the controller to come back to many, many instances and many, many applications. You might want to collect a different preset for a move and settle. You might want to have a different preset for a contouring accuracy application. Really, it's up to your creativity. And finally, you can create a new preset from the configure signals or edit plot dialog. And this is really convenient because it's been integrated right where you collect data anyways. So when you're in the data visualizer module, you'd open one of these two tools, configure signals or edit plot, and you would configure the plot as desired for the preset, and then you just click convert to preset. You fill out the convert to preset dialog that pops open, including the name and the description. You choose whether or not you want to include visible signals only or some of the non-visible signals that might be there, and then you hit convert, and it will convert it to a preset. Now I will note that you cannot reopen a preset from this view and edit it. You need to go back to the configure workspace to do that. But it is possible to edit something after you've actually converted it to a preset in this dialog. And finally, a new feature that I thought was worth noting was a new help file feature for PSO fixed distance pulse outputs for the GL4. And this example demonstrates generating a sequence of pulses each time the vector sum of a tracked GL4 axis moves a fixed distance, and more specifically, this program will track the average of the two encoders of each GL4 axis. To help you visualize the behavior of the PSO, some special provisions and instructions are provided in this help file. So if you're using GL4s and you're using PSO, take a look at this help file, run this program, and it'll help you better understand what's going on. Moving on to studio improvements. The first one that you will see or notice, hopefully, is the connection screen improvements. Now the Studio and Status Utility connections screens provide more information about the connection. In the parentheses, they'll show up as local, USB, or the IP address, or the host name for each controller will show up. It gives you a little bit more context about where you might want to connect if you're not sure which named controller is actually on your local PC or which one is a remote drive-based controller, for example. We've also made an improvement to adding 2D and 3D signals. And in this screen, I'm showing an example of adding a 3D signal where you follow the prompts to configure the X, Y, and Z components of the signal. Of course, if it was a 2D signal, there would not be a Z component. And then you set the period and the number of points that you would like to collect. You click on the signal to adjust the color, data labels, scale factor, and offsets of each signal. We made some improvements in machine setup. Some new stuff here is that we now have current loop gains are now calculated for voice coil motors and a valid electrical device. That does not apply to the XL4S. The reason is the XL4S does not have parameters for its current loop. It is an analog current loop that is specified by real circuit components. But for other drives where you can actually set values and the digital current loop, or machine setup does that for you. It also configures IXR3 and XR3 amplifiers even if the amplifier is not installed. The caveat here is that a control card must be installed for that access. You can also enter the work point diameter now for a rotary stage, which will be programmed like a linear stage. This is very common for people doing stent manufacturing or hypotubes. They actually kind of wrap a flat pattern around the circumference of a tube, and therefore the rotary axis is programmed like a linear. Well, to do that accurately, you need to know the diameter or the geometry of that tube itself so the counts per unit is correct. Some improvements we made some improvements to the parameter setup for the average current threshold and for the home setup parameter. See your release notes for more on that. And we also improved the error notification schemes for drive-based controllers connected to hyperwire drives that have current errors on them, and then machine setup errors when specifying an invalid access name. That was improved. On the variables and IO module improvements, we made a whole bunch of improvements here. You can now expand or collapse all the items. You can change the sort direction and order of these items as well. And improving the UX for all of our users. The industrial Ethernet items are now prefixed with a $sign to agree with their use in Arrow script, so there's no longer that point of confusion. You can filter, and the filtering now includes items that are not currently visible. A message is displayed when a category does not have any items to show, and that is the second screenshot there of the output words. That is part of the industrial Ethernet configuration. There's nothing to show there, and we give you a little message notifying you. And then keyboard shortcut information shows up as a tooltip, and you can see to edit that task string variable 0, you can click the edit button or you can hit the E button on your keyboard. Other studio improvements include the frequency response module. We simplified the unconfigured filters in the servo filtering editing toolbar, and that is the top screenshot on the right. Made that a lot simpler. In the device catalog, we added custom belt drive linear stages in the device catalog. So you can configure a bunch of settings for these custom belt drive linear stages, as well as just add them to the device catalog. We also have the absolute encoder alignment module, which now detects when incremental and absolute encoder signals are counting in opposite directions. And this is useful when you're setting up NDET or BIS absolute encoder feedback devices that include incremental signals. Moving on to some controller improvements. One of the things that we're really excited about here is this new feature for transformations. You can use the transformation execution order parameter with IFOV, or infinite field of view, for more flexible implementations. And this was really useful for some of our more advanced laser scan head devices, 3D and 5D scanners, so that infinite field of view can now be used with those more advanced tools. In addition, we also added to the drive array to increase the bandwidth the drive array write can function at. It's now at 200,000 bytes per second on a single axis, with some multi-axis drives having a higher bandwidth. So the first table up above shows what we had in 2.7, and where we had 48,000 bytes per second. And now many of these drives, especially multi-axis drives, can write up to Well, the highest one there we have was 800,000 bytes per second. This really increases the speed of drive array writing or writing to our drive array in Automation 1. More improvements on the controller side, something that we've been waiting for here for a couple releases and are excited to have are virtual binary bits. We added virtual binary input and output bit data items to get the value of a single bit of our virtual binary IO array. This is a whole mouthful, but what do you get for this? Now you can save or change virtual binary IO and you can write logic around it, including over here in the edit condition logic editor. This is inside of a machine app for a custom button. So now you can have custom buttons show different states based upon virtual binary input and output bits. It's very useful to do this when setting up state logic for your custom buttons and your custom indicators in a machine app, which is the HMI tool in Automation 1. In AeroScript, we also added 2 integer to string AeroScript functions, and this is to convert integer argument to a string with a different number base representation and a minimum width. We improved user safety. The AeroScript compiler will now generate a warning if a function expects an enumeration type, but the argument passed to the function is not fully the same as the expected enumeration type. So if we don't get what we expect, we're going to give you a warning. Moving on to help improvements. And we treat the help as if it's part of the product because it purely is. The help homepage and improved navigation have both been released in this 2.8 release. This improved homepage includes links to hardware manuals, and the main section pages include quick links and links to other resources. We also have more complete help content. An example of this is a motion section, which includes several topics. So I'll use my mouse again. If you look over here in the motion section, several topics are underneath motion. I'm actually looking at the corner rounding function section right here. And another example is data collection and controller status. Again, this section of the help topic includes several topics, and it's really better organized and gives you a better shake in understanding the full breadth of a topic that the Automation 1 controller covers. Looking at machine apps improvements. Again, machine apps are HMI tool in Automation 1. We added machine apps button keyboard shortcuts. This was a feature that was very popular in our A3200 controllers CNC operator interface tool, where you can have accessible shortcut keys with your F function keys. We added that into the machine apps tool, backed by popular demand. So in the machine apps workspace for any machine app with buttons and indicators in the layout, you could open the edit module configuration dialog, and then you would click on this pencil button. Again, I'll use my mouse, it shows up here in the top right, and clicking on that button will open the edit shortcuts dialog, which I'm zooming in on here. You can edit the shortcut for any or all buttons, then click save to close the dialog, save being right here. And then to quickly remove a shortcut, you also have the ability to use the trash can icon to the right of the shortcut label. And the nice thing about this is a shortcut naturally becomes part of the button that's accessible when you go to use that machine app or that HMI screen. Whatever you set it up to be, in this case I'm looking at the Enable X button. That's part of a different machine app, but I set that up to be Control plus F3. I can home using the F4 button, and I can disable using the F6 button. Again, as more of a reminder, not as a new piece of news, but custom modules and machine apps remains in beta. I got a couple nice new screenshots for this version of the release notes. So first off, many of the modules in this screen you see are standard modules, meaning you can do this out of the box with machine apps. Custom modules is a tool that allows you to use .NET to develop your own module that opens up as a standard module in machine apps. And this is one that we did for our own internal purposes. We created a .NET module, and this is a laser recipe manager custom module. So we have a laser tool that we're imagining that we have, and we're saying how can we quickly change the recipe for that laser tool, like many of our customers do use industrial lasers. You guys can do the same thing, or you can work with our ATG group to develop a custom module for your application. Doing things like this, and it also works with vision tools, Cognex cameras and such. You can really use a lot of the Aerotech standard modules plus 1 or 2 custom modules to quickly deploy a very nice custom user interface for your front end of your machine. Please reach out to Aerotech if you're interested in this. we can help you get started with custom modules. And again, this recipe editor custom module we just showed you in the video, that shows up in your GUI, in your Automation1 Machine Apps workspace like a standard module. So when you're designing your layout screen, you drag and drop it in just like Aerotech supplied camera, data visualizer, jog pad standard modules. Another nice improvement we made in Machine Apps, and if you're using this tool, you've probably seen this before, for added consistency, no matter what size your screen is, we added the ability to specify which buttons and indicators show up on the left/right column or the top or bottom row by turning off a feature called auto column wrapping or auto row wrapping. Okay, so when you turn this off, what you see is this column break identifier shows up, and you can use the reorder buttons to place that column break, or it could potentially be a row break, anywhere between these two sets of buttons, okay, or indicators. That means that that column break will be consistent whether the machine app is maximized or shown at a smaller screen resolution. It's a nice new feature, gives you a little bit more control. We also increased the maximum number of buttons and indicators per page. It's now 20, it was 12. A lot of screens are big, a lot of screens can tolerate more buttons. You can now use more buttons and indicators. New name, just so you know, buttons and indicators has replaced what was once called customizable buttons and indicators. Because you're doing HMI development, it's pretty much assumed that they're customizable because that's what we provide to you. We also improved a different module inside of Machine Apps, but we gave you the ability to use multiple variable and IO instances inside of a machine app. Moving over to drive hardware support. New firmware features include improved brushless motor commutation initialization, and you can use feedback from a sine wave incremental encoder to initialize commutation for a brushless motor now. We have faster feed forward gain updating, and you can gain your acceleration and velocity feed forward gains at the 20 kilohertz servo rate, or for Galvo or laser scan head devices at the 100 kilohertz rate. The controller will automatically synchronize the updated feed forward gains to your move commands. We also now include tachometer mode, so you can use a tachometer connected to an analog input as a feedback input for the servo loop. We also now include current-based limits on more drives. This is an end of travel limit type that will detect a current spike and treat it like a limit switch. We also now have bus voltage data signals. We added bus voltage signals that help to debug problems with the motor supply for your axis. See the release notes for more information. And coming up, a product we're very excited about in this July are the new IA4 and XA4 versions and options. And these versions and options include a 4-axis version of the drive. That's what's shown here in these images. We have an IXA4 on the left and an XA4 on the right. The difference being the IXA4 can run the full Automation1 ISMC controller. We're going to have DC-based power supply versions of these drives. Advantage being the DC-based versions don't have an internal power supply and end up being a little bit less expensive than the current AC power supply versions. And then we also have the EB1 and EB2 expansion board options. Shown in both of these images are the EB1 high-density expansion boards that have twice the I/O as our normal I/O expansion boards, say for our XC4 and XC4E products. And really, guys, the XA4 can do it all. It works with Machine Apps and Automation1 APIs, .NET C and Python, LabVIEW, Epix, and Tango for other users. It has STO for integration with safety controllers. It can support EtherCAT and also Modbus. Ethernet IP support is pending. And of course, the blue box on the left with the full controller, the IXA4 is extendable. It's extendable with Hyperwire. So you can connect these two drives together and get an 8-axis system. You can actually connect one more XA4 4-axis device and have 12 axes of motion being controlled by the IXA4 motion controller. So it's a very powerful product. It is the right price for the right time in the market, and it's something that anybody who really enjoys motion control and has a typical application for motion control should be asking Aerotech about. It's a very exciting product. So that's it. That's all I have for today. I want to thank you for watching this motion control platform release update. I hope you enjoyed learning about all the new features which are available in the 2.8 Automation1 release.